Hi guys, it's Mrs. Milson. I want to talk about DeMorgans Law from a conceptual standpoint before we talk about the code. Okay, I'm going to do this by way of a Venn diagram. Okay, so in our Venn here, we have two categories: students that take AP classes and students that are juniors. Okay, I have 10 students that are taking AP classes and are juniors. I have 20 students that are taking AP classes but are not juniors. And I have 15 students that are juniors but not taking AP classes. And then out here I have 30 students that are not taking AP classes and they're not juniors. So I have a total of 75 students represented in this Venn. Okay, so if I wanted to know the proportion of students that are taking AP and are juniors, okay, in code, that would be AP and then the double and sign. And those students have to satisfy both conditions. They have to be taking AP class and are juniors. That would be our 10. Okay, so we have our 10 out of 75. Now, if I was to negate this, okay, so if I put the exclamation point in front, okay, AP and juniors, this is basically everybody that is not those 10 people. Okay, so not those 10 people would be the 65 out of 75. Okay, now if I take this, the not exclamation point, and distribute it, and I'm using the word distribute loosely, and which is what DeMorgans Law says, this will become not AP or not juniors. Okay, so the students that are not AP are all these students, and the students that are not juniors are all these students. So basically, it's everybody but the 10. Okay, so this will give me that 65 out of 75 again. Okay, let's do another one. All right, and again, I'm bringing this to you from my AP statistics standpoint. Okay, all right, the other one, let's do an or. Let's say I want to find all the students that take an AP class or, oh, I didn't mean to do that yet. That's the code, not the word. Let's do this. Or are juniors. If I was going to code that, that would be AP and then those double lines. We saw that up there. Juniors. That would be all of these, because with an or statement, the item has to satisfy at least one of the conditions. So here's all my AP and here's all my juniors. So I would just do, let's see, 20, 30, 45. 45 out of 75. Okay. Now, if I negate that, if I negate AP or juniors, okay, it would just be those 30 students because they're the only ones that are not AP or juniors. Okay, so it would be the 30 out of 75. So now if I distribute this through following DeMorgans Law, it will become not AP and not juniors. Okay, which on our Venn diagram are those kids. These kids are the kids that are not taking AP and not juniors. Okay, so we can see they equal the same thing. Okay, so again, hopefully this isn't too confusing, but just showing how when you use DeMorgans Law and you carry through that not negation, it turns ands to ors and ors to ands. Okay, all right. Let me show you a little bit on Dr. Java. Let me minimize this and we'll do some coding. Okay. All right. So I created a DeMorgans class file here. Let's just start with a couple ints. So I'm going to have int A equals 5 and int B equals 10. Okay. So just as a note, let's put some little notes in here. DeMorgans, capitalize, law says if I not an and, sorry, A and B, let me put some space, and B. This is equivalent to me, again, I'm going to use the word distribute, but loosely, not A or not B, okay? And on the converse, other side, it says if I negate A or B, it equals not A and not B. Okay, so let's see this in action. Okay, I'm just going to do a couple printouts. Okay, let's do a conditional here. Okay, I'm going to say A equals 5 and B equals 10. Okay, we know that's true. All right, they both equal what they're supposed to equal. We know that this should yield us true. Okay, so let me compile. What did I forget? Oh, got that capital Y in the middle of there. Let me make this a little bigger here. Okay, so when I run this, I should just get a true printed out. Okay, because I know A does equal 5 and B does equal 10. Okay, now if I take this, I'm just going to copy and paste, save myself a little bit of typing time. And I'm going to put this part in parentheses. And then I'm going to negate the whole thing. Well, if this was already true, the opposite is false. So this has to be false, okay? Because originally inside it was true, but then I'm saying do the opposite, okay? So I should print true, false. Okay, and indeed I do. Now let's distribute this, the not exclamation point, and we'll change. I'm just giving myself some space. So I'm going to say A is not equal to, okay, because that would be the opposite of being equal to, and B not being equal to, because again, that'd be the opposite, and I have to change my and to or. Okay, now according to DeMorgans Law, these two should be the same thing, okay, because when I distribute that not through, it changes the and to or, and everything becomes the opposite. Everything becomes the not what it was before. So this should also be a false because this is the same as the line above, okay, according to DeMorgans Law. Okay, so there we go. I got true, false, false, which I should have. Okay, all right, let's do another one where we start with an or and go to an and. Okay. Let's see, what do I have here? Well, you know what? I'm going to put an empty space just to give us some space when we run it. Okay, let's do A is greater than 8. I'm going to do another and B is less than or equal to 10. Okay, so let's figure out if this will be true or false. Is A greater than 8? No. Okay, so for an and, both conditions have to be satisfied. B is less than or equal to 10 because it's equal to 10, but A is not greater than 8. So this is going to be false. Okay, if I run it, it's false because both conditions are not met. Okay, so I got a false. Now let's negate it. Copy and paste. Give myself some space here. Okay, so if I negate this with an exclamation point, it should be the opposite of false. It should be true. Oops. Okay, so let's look at that. Okay, and it is. And then if I distribute this or rewrite this according to DeMorgans Law, I will distribute that not exclamation point. So what is not A is greater than 8? Well, the opposite of A is greater than 8 is less than or equal to 8. Okay, and what is the opposite that B is less than or equal to 10? It's B is greater than 10. So of course I have to change this to an or. Okay, so these two lines are the exact same thing according to DeMorgans Law. So this should also compile and run as true. Oh, forgot to take out those ands. Okay, so let's run. And indeed it is, because again, these two lines are the exact same, okay, same as above. And according to DeMorgans Law, okay? All right, let's do one more set. Let me copy and paste this. Get another blank line in there. It's always nice to have a visual break, an eye break. Okay, this time let's start with an or. I'm going to do A is greater than or equal to 2. Okay, so I know that's true. Or B is less than 1. Okay. Oh, too many parentheses. Okay, so if I look at this, A is greater than or equal to 2, or B is less than 1. Well, with an or, only one has to be satisfied. And this one's true, so therefore this whole thing will be true. Okay. Oops, run. Okay, and it's true. Let me scroll down a little bit. So now let's negate it. Okay, we'll put that exclamation point. Again, I'm going to copy and paste. My spacing is a little weird. Let me put that inner part in parentheses and negate the whole thing. So of course, if I negate a true, it will become false. Okay. And there's my false. Okay. So now if I take the exclamation point and distribute it through, copy this whole thing. According to DeMorgans Law, okay, I'll get rid of it. What is the opposite of greater than or equal to? Well, the opposite of greater than or equal to is less than. What is the opposite of less than? Well, that would be greater than or equal to. Okay, and then of course I have to change my ors to ands, and these two lines are exactly the same according to DeMorgan, so this should also be false. Okay, so we say run. And there we go. Okay, so we've got my true, false, false. Now, whether you want to write out your compound or statements and and statements like this, or if you want to write like that, that is totally a programmer's choice. They mean the same thing. No one is more correct than the other. I like the worked out one because I've kind of already dealt with the not exclamation point, and to me this one's a little easier to read. Sometimes these always confuse me because I got to think about this way and then I got to think the opposite. But it doesn't matter. They're the exact same thing, so it doesn't matter which way you code it. Okay, but just you need to be able to recognize when DeMorgan's law is being applied, especially for like a multiple choice question on the AP test. Okay. All right. I think that's it for DeMorgan's Law. Hopefully that makes it a little clearer. And again, it's just one of the many parts of code that you're going to learn. Okay, it's not the single most important thing, but it is an interesting little pattern that shows up with our and or statements when you try to negate them. Okay, great. I will see you next time. Bye bye.